So this is another problem that we're going to work on. So we're going to express the numbers in the form of a table. So we have x and y. So x is really whatever is going to go on the x-axis. Y was whatever is going to go on the y-axis. So we're going to have y. X is 1, 2, 3, 4, and 5. And the corresponding y number is going to be 2, 4, 6, 8, and 10. So if you really wanted to be particular, we could say that is 1, 2 coordinate, 2, 4 coordinate, 3, 6 coordinate, 4, 8 coordinate, and then 5, 10 coordinate. Okay, so what we're going to do is we are going to draw this line. Okay. And then we're going to draw the line first, and then we're going to do something else after that. So we're going to have the y-axis here and the x here. And what we're going to do is we're going to make the x go 1, 2, 2, 3, 4, 5. And then we're going to have 2, 4, 6, 8, and 10. Now you might say, why didn't you make it 1, 2, 5, 6? You don't want to do that, because if you made each axis exactly the same in terms of the hash marks, your graph would look all over the place. So we're going to graph these numbers. We're going to go across 1, which is the run, and rise is 2. Okay, so we have 1, 2. Then we are going to go 2, 4. So we're gonna go from 0. So it's not from 1 to 2. It's from the origin. So we're gonna come across 2 from the origin, right? Remember where the lines meet. So it's gonna be 2, 4. So the mistake people make is they might just jump 2 over, and you don't do that. So it's 0 to 2, and then up 4. So we have 2, 4, and then now let's do another one. Let's do 5, 10, right? So what do? They come across all the way over. That's your 5, and then go up 10. So we have 5 and 10. So we've done the graph. Have we done the graph? Yeah. Now, what we want to do next is we want to do the slope. And in the real world, meaning in the business world, they actually might be saying, okay, we want to know exactly how, when we do one thing, how does it affect another thing? Like if you want to affect some sort of production, how does it affect the money coming in? Either way, this actually does have real world implications when we put it on a bigger level, right? So the slope, remember, is what? Rise over 1. Or, if you remember from your previous notes, it's the change between any 2 points on the y-axis over any 2 points on the x-axis. And since it's change, you have to have 2 points, right? Just like if your weight changed to be, let's say, 1 whatever, and then you're 1 whatever, right? Or the time of the test change, it was 9, now it's 8:30, right? You have to have 2 things. So what we're going to do is we're going to look at, since this is a linear equation as well, and how you know that is, the reason why you know it's linear is because if you've drawn this correctly, your straight line, that you know it's linear because this changes by the same, like 1, and this changes by the same as well. So this is 2, 4, 6, 8, 10. This is 1, 2, 4, 5. So we know the next number is 6. We know the next number is 12, 7, 14, and so on, right? So now what we're going to do is we know that the first number is x1, first y1, x2, y2. So what we're going to do is we're going to go 4 minus 2, y2 minus y1, over x2 minus x1, which is 2 minus 1, and the slope is equal to 2. And we could do that for any of the 2 points. We could go between like 2, 4 and 3, 6, 3, 6 and 4, 8, 5, 8, doesn't matter. Or we could go all the way back from 5, 10 to 1, 2. Doesn't matter. Any 2 points the slope is the same, and this slope is positive. How do you know that? Because there is no negative sign beside that, which tells us that the slope is positive. So thank you and good luck on the problems for grades.